we discuss about non-uniform velocity. For non-uniform velocity, average velocity. Average velocity. Average velocity. What do you mean by average velocity? For non-uniform velocity, the average velocity is defined as the ratio of total displacement to the total time elapsed. Total time taken. Total time taken. Now, the average velocity is written in this way, V average, and it is written as displacements, total displacement S1 plus S2 plus S3 plus S4 etc. by total time taken T1 plus T2 plus T3 plus T4. That is, in T1 time displacement of a particle be S1, at T2 time the displacement of the particle be S2, and so on. We see that is the path of the motion. Starting from O, now we take different points A, B, C, and D, C and D. Now, it is the path of motion. This is the path of motion. Now, from O to A, the displacement will be obtained by joining O and A by a line segment, and its direction will be the initial to the final point, that is from O to A. Its displacement is S1 and time taken be T1. This is S1 and time taken to reach A from O is T1. Similarly, at B, displacement will be obtained by joining A and B by a straight line segment, obviously, and displacement say S2, time taken T2. Similarly, the displacement from B to C will be S3, time taken T3, and C to D, displacement will be S4 and time taken will be T4. In this way, we write V average is the sum of the displacements by time taken. It may be written as del S by del T, or summation S by summation T may be written. Now, if like the average velocity, it also depends upon the time taken. If T4 is omitted, then displacement Some of the displacements will also be changed, and apparent velocity will also be changed. Now we know about uniform acceleration and non-uniform acceleration. Uniform acceleration. Here we have the definition as follows. Uniform acceleration and it is denoted by A. It is a vector quantity, hence we write an arrowhead above the letter A. If a moving body or particle changes its velocity, in equal amounts, for equal intervals of time. However small the time intervals may be. However small the time intervals may be. Uniform acceleration. If a moving body or particle changes its velocity in equal amounts or equal intervals of time, however small the time intervals may be. Now, we know about non-uniform acceleration in a lucid way. That is, we add with uniform as non-uniform, not non-uniform acceleration. If a moving body or particle changes its velocity in equal amounts, here we write in unequal amounts. Here we just add unequal. Unequal amounts for equal intervals of time. This not to be required to write. Non-uniform acceleration. If a moving body or particle changes its velocity in unequal amounts for equal intervals of time, then the velocity, then the acceleration, then the acceleration of heat of the particle or body is called non-uniform acceleration. Non-uniform acceleration. If a moving body or particle changes its velocity or increase in velocity actually in equal amounts for the case of acceleration or equal intervals of time, or in unequal amounts for equal intervals of time, then the motion is called, and the acceleration is called the non-uniform acceleration. Instantaneous speed or instantaneous velocity or instantaneous acceleration. Instantaneous speed is the speed of a moving body or a moving particle at a particular instant of time, or at a point of its path, at a particular point on its path. Similarly, velocity, instantaneous velocity is defined as the velocity of the particle at a particular instant of time, and it is obviously the average velocity when the time elapsed becomes tends to zero. That is, intervals of time compressed into small amounts. That is, instantaneous velocity V equal to delta S by delta T, with time delta T tends to zero. That is, delta T not zero but tends to zero. This is the instantaneous velocity. That is, instantaneous velocity is the velocity at a particular time. But it is the average velocity when intervals of time becomes negligibly small, infinitesimally small. In the similar way, instantaneous speed is the speed of a particle, moving particle, at a particular instant of time, or it is the average speed when time intervals tends to zero, that is, time intervals infinitesimally small. In the similar way, instantaneous acceleration will be the average acceleration when at a particular instant of time is also the velocity of the particle when the time intervals tends to zero, that is, time intervals becomes infinitesimally small. Now, we know some equations of motion for uniform acceleration. Before this, we know about translational motion and rotational motion. Translational motion, these are the types of motion. Translational motion and rotational or circular or revolutionary motion. Here, just see, we define translational motion of a body is that which, when the whole parts of the body covers equal distance in a particular time. All parts of the body covers equal distance at a particular or at a given time. Translational motion are of two types: rectilinear motion or curvilinear motion. When, in the case of translational, when the whole body moves along a straight line, along a path, that is one-dimensional motion, then it is called rectilinear motion. This is one-dimensional. If we take it as O and this is x-axis, then it moves along the x-axis or y-axis or z-axis only. Rectilinear motion is the motion of a body, whole body, when moves in a straight line path. And curvilinear motion is the motion of a body in a curved path, as a whole, moves as a whole in a curved path. Now, we know about revolution. revolution. What do you know a revolution? Revolution is the motion of a body as a whole about a point or about a axis. That is, this is the point O and this is the axis OY, and the body as a whole moves round this. Then this is called revolution. For example, Earth moves round the sun, Moon moves round the Earth, and so on. And in the case of rotation or circular motion, obviously both are circular motion in a circular path. Rotational motion means if a body itself moves along an axis in a circular path about a point on its axis, then the body actually does not change its position from one place to another, then this type of motion is called rotational motion. For example, the motion of the blades of a fan, electric fan, and running it. Now, rotational motion, in the case of rotational motion, if the body moves, or in the case of revolutionary motion, if the body moves along a circular path with uniform speed, this is the axis of rotation, with uniform speed the body moves along a circular path with uniform speed v. At any point its velocity will be same. Then this type of motion is called the uniform circular motion. This is called uniform circular motion. Now, we know about the equations of motion for uniform acceleration. For uniform, we define it. For uniform acceleration, that is a, here we takes only the magnitude, hence no vector sign, that is arrowhead is given here. For uniform acceleration, the following equations of motion are very important, for solving mathematical problems. Various mathematical problems. Various mathematical problems. Various mathematical problems. What are the equations? Number 1, V equal to U plus AT. Where V is the final velocity, U is the initial velocity, A is the uniform acceleration, and T is the time taken. Number 2, S equal to displacement, ut plus half at square. Number 3, v square equal to u square plus 2as. And lastly, st equal to u plus half a 2t minus 1. These 4 equations are very important. V equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2s and st equal to u plus half a into 2t minus 1. Here u equal to initial velocity of the body or particle, v equal to final velocity, a equal to uniform acceleration, s equal to distance covered, t equal to time taken, and st equal to distance covered in teeth second, distance covered in particular time, teeth second, but teeth time. Now, what is the distance covered in teeth time? That is the total distance covered by the moving particle or moving body in t second, and in t minus 1 second is subtracted from the value of total distance covered in teeth second minus total distance covered in t minus 1 second is equal to st. That is, to consider this as 9 seconds and displacement is s9, this is s9, and just before 1 second, that is 8 seconds. In 8 seconds, the distance covered will be s8. Then this is s9, s and s dashed, write it, s and s dashed. Then this is st. St will be here s minus s dashed. That is distance covered in 9 seconds minus distance covered in 8 seconds. Remember it. Now, equations of motion are very important. You write, all of you write in your exercise book. Now, we give some graphs. At first, we give displacement time graphs. Displacement time, this is displacement versus time graph. For uniform velocity, that is uniform motion, uniform velocity or uniform velocity or uniform motion, that means uniform motion also, OX. Here we denote x-axis as time axis, that is time is given in the along the x-axis and displacement is taken along the y-axis. Here we don't give the arrowhead because we take only magnitude, not its direction. For uniform velocity, that is displacement of the body increases uniformly with time. That means it is a straight line OA. We take the graph in a different color so that it will be prominent. this is OA. OA will be the displacement time graph when the velocity is uniform. Here uniform velocity means the gradient of the velocity time graph. This is the velocity time graph. This is displacement time graph, ST graph for uniform velocity. Now, if the body is at rest, then what will be the displacement velocity time graph? Displacement time graph. That is, if the body is at rest. For a rest body, or a stationary body. For a stationary body, here we always plotted the graph by taking time along the x-axis and displacement along the y-axis. Here, for a stationary body, that is the body is at rest, the velocity time graph will be a straight line parallel to the time axis, that is parallel to the x-axis or abscissa. Because in this case, no velocity, no displacement actually occur. Here, velocity at time, this time is this, and after this time, velocity is displacement is that is displacement does not change at all, and so the body is at rest. For a non-uniform velocity, it will be a curve. It will be a curve. Non-uniform. In the case of non-uniform, we have OX, OY, time along x-axis, speed, displacement along y-axis. In this case, the graph will be a curved path. Like this. This is the non-uniform. That is slope changed. Slope means tangent drawn at the various points, and angle made with the x-axis, positive direction of x-axis. Then if you take tan of that angle, gives the slope or gradient of the graph, OA. Here, this is for non-uniform velocity. Non-uniform. Here, not uniform, non-uniform velocity. In a similar way, we have velocity time graph. Velocity time graph. What will be the velocity time graph? We write them. VT graph. Here we will write VT graph. V means velocity. V means velocity, not displacement here. VT graph. Velocity versus time graph. Velocity versus time graph. VT graph for uniform acceleration. For uniform acceleration. For uniform acceleration, what will be the VT graph? Velocity versus time graph. The graph here, time is taken along x-axis and velocity is taken along y-axis. O is the origin. If the body has some initial velocity, then the graph will be of this type. AB will be the velocity time graph for different points. Velocity time graph. Here, this is O to A denotes the initial velocity. O to A denotes the initial velocity. This is O to A, initial velocity U. And if we draw perpendicular from B on the x-axis, that is, this will be the velocity, final velocity. This will be the final velocity. Now, if the body starts from rest, Then the velocity time graph will be this type, that is, this part is absent. That is a straight line, passing through the origin. Just graph will be the same kind, same type, but it is passed through O because no initial velocity is present here. No initial velocity u equal to 0. This is the v, this is t, initial velocity. It is a vt graph, v versus t graph, or uniform acceleration having initial velocity u. Here no initial velocity. Without initial velocity, vt graph, v versus t graph, without initial velocity, that is, the body starts from rest. And the zero acceleration graph will be this type. Here we write zero acceleration graph. O, x, y, time along x-axis and velocity along y-axis. Then the velocity does not change because acceleration is 0. This will be the velocity time graph, AB. Velocity time graph or zero acceleration. And for retardation, uniform retardation, the graph will be this type. For zero acceleration, VT graph. For retardation, the graph will be this type. V along y-axis. This uniform retardation. Graph will be this type. Uniform retardation. That is, it starts from some velocity, final velocity, and then its velocity decreases uniformly. Alright, graph, VT graph, V versus T graph for retardation, uniform retardation. In next class, we know something about problems related with these equations, that is V equal to U plus AT, S equal to UT plus half AT square, B square equal to U square plus 2S, or ST equal to U plus half A to 2T minus 1. Right? Okay.